Hello and welcome to this video lesson where we'll explore subtracting integers. Our learning goals are, I can subtract a number by adding its additive inverse, and I can express a difference as a sum. And our language goals are, I can talk about integers using words like integer, positive, negative, sum, difference, and additive inverse. Before we begin, let's see if we can make some connections to what we already know. An integer is a whole number that can be positive, negative, or zero. Positive integers are greater than 0, negative integers are less than 0. We can represent integers with counters, number lines, and numbers. An integer's magnitude is the same as its distance from 0 on the number line. When we add a positive integer to a negative integer, they cancel each other out, making a zero pair. We can show any number in many different ways by adding 0 to it. A number and its additive inverse are the same distance from 0 on a number line, but on opposite sides. Another key thing to know about additive inverses is that when you add them together, they cancel each other out and make 0. That's going to be the basis of our new concept for this lesson. Subtracting a number is the same as adding its additive inverse. This concept works even if we stick with only positive integers, which we're very familiar with. Let's look at this very basic example, 5 minus 3. First, we'll rewrite the expression. 5 is the same as positive 5, so let's include the plus sign, and 3 is the same as positive 3, so let's include the plus sign there as well. Now, it's really clear that when we subtract in the way we've always been used to subtracting, we're subtracting a positive integer. Then let's apply our new concept that subtraction is the same as adding the additive inverse. So instead of subtracting positive 3, we will rewrite the expression as adding the opposite of positive 3, the inverse of positive 3, which is negative 3. So we put a plus sign as the operator symbol to show addition. Then we rewrite positive 3 as the additive inverse, which is negative 3. So our new expression is positive 5 plus negative 3. Now, let's use counters to model this new expression. We'll start by adding 5 yellow counters to show positive 5. Now let's add 3 red counters to show us adding negative 3. Next, we find any 0 pairs. Here we have 3, and we are left with 2 yellow counters, which is the same as positive 2, and that should come as no surprise to anyone, since I hope we all knew from the very beginning that 5 minus 3 would give us 2. Let's look at a different problem. This time we're asked to solve negative 6 minus 3. We can visualize this expression quite simply on a number line like this. The first term in this expression is negative 6, so we start at 6 units to the left of 0 on the number line. Then we see minus 3, which we interpret as telling us to move 3 units to the left on the number line. But let's rewrite this expression for clarity, remembering that the minus sign is the operator symbol telling us to subtract, and 3 means positive 3. So the expression negative 6 minus 3 really means negative 6 minus positive 3. Now, since we're all really used to just looking at the operator symbol to tell us which direction to move on a number line, expressions like this where we start left of 0 and then subtract a positive integer can be really confusing to visualize this way. We see minus as the operator symbol, which we have always interpreted as telling us to move left, right beside a plus sign indicating a positive integer, but we're really used to seeing plus signs as instructions to move to the right on a number line. So how do we know what to do? Well, here's a different way of thinking about it. Instead of thinking of the operator symbol as giving you instructions on which direction to move on the number line, use the new concept we just learned. Subtracting a number is the same as adding its additive inverse, and rewrite the expression again using the new concept. Now look at this new expression, negative 6 plus negative 3, and let's go back to our number line. We're still going to look at the first term to determine where to start. Still negative 6. Now, instead of thinking of the operator symbol directing those 3 jumps to the left, let's visualize what the unit negative 3 looks like on a number line. And we can see what that looks like here. From 0, we move 3 units left on the number line. And we can see when we do this, we see the magnitude or size of that integer, -3. Now let's add that integer, -3, to our first term, -6. We can do that just by moving our model of -3 over here to start at -6. And we see we still end up at -9. This shows us that both expressions, -6 minus +3 and -6 plus -3, are equivalent because they both represent the same integer, -9. And we can see how our new concept that subtracting a number is the same as adding its additive inverse works. Let's look at the same expression with counters to help visualize it, because sometimes people find counters easier. The expression is -6 minus 3, which we can rewrite for clarity as -6 minus +3. Then we apply the new concept that subtracting a number is the same as adding its additive inverse. This means we can now rewrite the expression as -6 plus -3. Now let's model it using counters. We model -6 with 6 red counters. The expression then tells us to add -3, so we add 3 more red counters. Now we have 9 red counters, which represents -9, so our solution, as we expected, is -9. Okay, so now we've seen how this new concept applies to subtracting positive integers. Let's try applying it to an expression where we have to subtract a negative integer. This time, the expression to solve is -4 minus -6. Let's start by rewriting the expression using our new strategy. Subtracting a number is the same as adding its additive inverse. We'll keep the first term the same, that's -4. Next, we change the operator symbol from minus to plus because we're going to add. Finally, we put in the additive inverse of -6, which is +6. So now we see our new expression is something a little easier to model on a number line or with counters. Let's try it out with both tools. First, let's visualize this expression on a number line. The first term, -4, tells us where to start. Next, we're adding +6. And let's remember that when we add and subtract with positive and negative integers, we're going to use the sign of the integer to tell us which way to move on the number line. In this case, 6 has a positive sign, so we'll move 6 units to the right. We end up at +2, so the solution to this expression is +2. Let's model it again using counters. Again, let's look at the first part of the expression, -4. We'll place 4 red counters to model -4. Next, we see the expression tells us to add +6, so we'll add 6 yellow counters to show we are adding +6 to our -4. Now we just need to locate the 0 pairs and see what's left to solve this expression. And once we've identified and discarded our 0 pairs, we see that we are left with 2 yellow counters, which represents +2. So we've got the same solution to this expression using counters as we did on the number line, which is good because if we got a different solution, we know we went wrong somewhere. I know it can be really hard to understand why subtracting an integer is the same as adding its additive inverse, especially when subtracting negative integers, but maybe this analogy will help you understand. Remember in my video on adding integers, we met Peyton, who wanted to buy 400 Robux for $7? We used this example to work out how much more money Peyton needed to save, but let's imagine Peyton borrowed the money instead of saving up. Imagine that her older brother gave her the $3, but as a loan, not a gift. This means that Peyton owes her older brother $3. If we represented Peyton's piggy bank as an integer after she took the loan from her brother, it could be represented by the integer -3, because she owes her brother $3. So she has a balance of -3. Now, let's say Peyton's dad feels bad for her and wants to take away her debt. To take away or subtract Peyton's debt, her dad gives her or adds to her piggy bank $3. We can represent dad's help as the integer +3. Let's walk through this again. To take away her debt, which we represented with the integer -3, he adds the opposite amount, which we represent with the integer +3. Now her bank balance is 0. So, to subtract or take away a negative, we added the opposite integer, the additive inverse. In other words, subtracting a negative integer, in this case, taking away Peyton's $3 debt to her older brother, is the same as adding its additive inverse, as her dad did when he gave her $3, the opposite or inverse of her negative $3. Time for a few practice questions. Let's work through this one together. We need to solve negative 10 minus positive 8. So first, let's look carefully at the expression. We see that it starts with negative 10, so I'm going to throw up 10 red counters to model our starting point. Now, let's apply the new concept we learned. Subtracting a number is the same as adding its additive inverse. How can we rewrite this expression, negative 10 minus positive 8, as an addition expression using the additive inverse of positive 8? Did you say negative 10 plus negative 8? If so, give yourself a big pat on the back. And if you don't understand how we got there, let's break it down. We'll keep the first term, negative 10. We don't need to change that at all. Now we're going to apply our new concept. Subtracting a number is the same as adding its additive inverse. So let's focus on the operation here. We're going to change subtraction into addition. So we change the minus sign to a plus sign. Now we've covered the first part of the new concept by changing the operator symbol. And then we have to be sure that we switch positive 8 for its additive inverse, which is negative 8. And now that we've rewritten the expression, we see that all we have to do is add negative 8 to the negative 10 we already have, like this. Now we have 18 red counters representing the integer negative 18. And that is our solution to negative 10 minus positive 8. We can also represent this expression on a number line. As always, we use the first term to determine where we start on the number line, in this case, negative 10. Next, we look at the sign of the next integer to determine which way to move on the number line. Which way should we move on the number line for this question? Did you say left? If so, you got it right. In this case, the next integer is negative 8, and the negative sign tells us to move to the left on the number line. Now, where will we land after we move? Did you say negative 18? We end up at negative 18, so we have shown that negative 10 plus negative 8 is negative 18. Since this expression is equivalent to the original expression, negative 10 minus positive 8, we also know that negative 10 minus positive 8 can be solved as negative 18. Now let's try the same thing with an expression involving subtracting negative integers. In this case, we are asked to subtract negative 6 from 5. Let's begin by rewriting the expression using the rule that subtracting a number is the same as adding its additive inverse, like this. Is this how you wrote it? If so, give yourself a pat on the back. If you're still a bit confused, let's walk through it. We keep the first term the same, then we have to change the operator symbol from minus to plus to show that we're going to add instead of subtracting. And then we find the additive inverse of negative 6, which is positive 6, and add that. Instead of subtracting, we're going to add the additive inverse, or opposite integer, which in this case is positive 6. Now we can rewrite this expression in an even more simple and easy way to understand, like this. We can also, of course, model this expression on a number line or with counters like this. We see that the answer is 11. Now here are a few problems for you to try on your own. The first problem is negative 5 minus negative 3. We start by rewriting the expression using the principle that subtracting a number is the same as adding its additive inverse, which gives us negative 5 plus positive 3, which we can rewrite again as negative 5 plus 3. Now you can model that on a number line or with counters if it helps, or you can figure it out using mental math and you arrive at negative 2. Our next expression is negative 12 minus negative 4. Let's start by rewriting it as negative 12 plus positive 4. Or we could just skip right to this step and rewrite it as negative 12 plus 4. Again, if it helps you to model this more simplified expression using a number line or counters, go ahead. If you can arrive at the solution using mental math, that's great too. Either way, you should arrive at negative 8. Now let's review what we learned in this video lesson on subtracting integers. We learned that subtracting a number is the same as adding its additive inverse. We can think about subtracting negative integers using the analogy of Peyton's dad. He took away or subtracted her debt, -3, by adding the opposite amount, +3. Since -3 and +3 are additive inverses, in other words, when you add them together, they make 0, this shows how subtracting a number is the same as adding its additive inverse. We know that an additive inverse is a number that when added to any given number gives 0. Another way of thinking of this is opposite integers. The additive inverse of any integer is the number that is the same distance away from 0 on the opposite side of a number line. And when you add additive inverses together, they always equal 0.